Can everybody please pay attention? We're going to get started. Thank you.
Hello, everyone. I can't project my voice super loud right now, but I'm Dr. Rico. Welcome to our kickoff event for the Quadcopter Challenge. We're super excited to be here. Welcome to the University of Hartford. Like I said, we're super happy to have the Quadcopter Challenge going again. We had to take a year off last year. We're glad we can get going this year. So today, hopefully you can get going. People whose teams aren't here, you can bring this excitement back to your campus. And it's going to be an awesome challenge. It's a really cool event, really cool project. So I'm excited for everyone to be here. I want to introduce the Dean for the College of Engineering, Technology, and Architecture here at the University of Hartford. He just wants to say hi real quick. He's the one that helped make, this is a new building that you're in right now. We just had got access, this is our second semester in it. So you guys are like the first event to be here. It's pretty exciting. So awesome. This is Dean Alger. Yes. Previous director. Yes.
Yes. Thank you. Good morning, everyone. I didn't think that will take place because we were worried about the university. I think starting next Monday, we are not allowing anybody on campus, basically, except students. So you made it through, and you made it through because Professor Rico, she just like got the approval, and the university didn't change its mind. So thank you for being here. Welcome to the university, College of Engineering, Technology, and Architecture. You will see around, this is a new building. It doesn't look like an academic building. It looks like a museum, or, with the hallway, with the open and the glass. As you know, academic buildings normally hallway and a door here and a door there. This is different. I hope you get the chance to see this place. This is fantastic. Maker space available to students to come in anytime and do whatever they want. We have small machine shop here. We have a big one in the main building. Supply room, it still says storage. Supply room and about 25 or 27 3D printers, laser cutter for students to come and work and do whatever they want. They don't need to be part of a course to do here. Robotics, if you get chance, this is where we are the only robotics program in Connecticut. Engineering, robotics engineering. There is a mechatronics and robotics engineering technology, I know, at Central. So we have the aerospace program, the biomed program. We have lots of program here. If you are interested in any of those, I know you are now thinking about the future, getting a job or going for a degree, right? So think about it, what you want to do. If you are interested in any of the program, we would welcome. We would love to talk with you. What you are doing is really is very essential for your own growing. You are getting some experience, some hands-on experience, which many students don't get. I think when we started this one several years ago, it was like, I don't know if they can do it, if they can build it. It's electronics, it's whatever. But the experience has shown us that students can do a lot of things. We have had great few runs, and I'm sure you will do more. So as you play, as you build it, you learn 3D skills, you learn programming skills, you learn control skills. Driving something like this is not easy. It sounds fun. It's not easy. I almost bought one a few days ago. There was one like, really, I want to buy it, but I'm not good at driving it. I still have the simulator driving. There's a software you can buy, and with use the same controller, you hook it up to the computer and you learn how to fly. I don't know if you are planning to do it with this group or not. There is one you can learn how to fly before you do the hard way. So I hope this will be fun. I know the Professor Rico and others and Jake will be supportive, and other campus director will help you go through this process, but I hope your day will be fun. And I just showed Jake that our testing area. So maybe if you one day want to come and test, you are confused where you're going to go and whatever, I hope the infection rate will go down and we'll open our campus again. And the net will be here, supply chain. If you order a net, just a net, it's supply chain. We are waiting where there is a huge testing area. You can fly inside the net without any problem. So again, thank you for being here and welcome to the university. Enjoy it. If you
All right.
need some noise, but just open the door and get out. Thank you.
All right.
So
So,
one last thing before I totally hand it over to Jacob. If you have any questions about University of Hartford, or if you want to kind of poke around when you leave, Carrie here is one of our Space Grant students, and she's also an ambassador for CETA, so you can ask her questions. And also Evan is our, I don't actually know what his title is, but he helps with recruitment and enrollment, and he can answer all sorts of questions about the university. And he brought some like materials and stuff like that if you're interested. So we're going to stop our pitch now, and we're going to come and talk about why we're here, and that's the fun stuff. So, Professor Spute, it's all you.
all right. So, I'm recording here, so I'll be looking a little bit at this just to make sure that this gets recorded. Welcome to the sixth one, this NASA Connecticut Space Grant Consortium Community College Quadcopter Challenge. We're going to cover a few things, and I'm actually going to change the recording to be able to get this PowerPoint a little bit more in there, so you'll be able to see the PowerPoint clear on the recording. We're going to go overview what the challenge is. We're going to start motivating that a little bit with some of the current stuff that NASA is doing. Let's ask people who are here. Has anyone heard of any interesting NASA-related news that might have to do, this is a leading question, that might have to do with a helicopter? On Mars, the Mars helicopter, yeah. So we're going to look at that a little bit, and kind of that plays into some of the stuff that we're going to be doing with the challenge. And then we'll go over some basics of quadcopters, how they work, batteries and power, so you understand and be safe with working with batteries, and then how to fly safely and legally and order stuff and that. So that's kind of what we're up to today. I've got a clicker here. So the NASA's Mars helicopter. Does anyone know the name? I do. It's Ingenuity or Ingenuity, depending on how you like to pronounce it. I go Ingenuity. Here's a video. All right, so that started off with some cute computer rendering stuff, and then we saw the actual helicopter in a vacuum chamber. Why would they put it in a vacuum chamber? Yeah, to simulate Mars' atmosphere. So Mars' atmosphere, kind of famously, Mars doesn't have the same sort of magnetic core and magnetosphere that keeps stuff from drifting away. So its atmosphere is way thinner than Earth's. But there is atmosphere there. There is stuff that you can push on with the blades, so you can fly there. The moon doesn't have an atmosphere, so there's nothing to push on with spinning your blade. So it doesn't really work there. But Mars, there is gas, so you can push on it. Here are some details. The flight time, up to 90 seconds once per day. So that's very short, right? The reason being, it has to recharge. So you'll probably, when you're trying to fly this stuff, get frustrated by you're trying to learn how to do things, and then your battery runs out, right? But you're going to get more than 90 seconds, right? You'll probably get, depending on what batteries you're using and how you're running it, 10 minutes, 15 minutes on a battery before having to swap out a flight time, which seems really low, but it's a lot better than that. So anyway, yes. On Earth, the altitude record for flying a helicopter is 40,000 feet. When you're flying on the Mars surface, it's at the equivalent of flying at 100,000 feet in Earth, right? Because of how thin the atmosphere is. So they had to make it as light as possible, being as strong and powerful as it possibly can be. So we can't simulate, or at least we don't have the money to pay for a big vacuum chamber to run our things in there. And it would be very difficult because then you wouldn't be able to test stuff outside of that. So we're flying under Earth atmosphere, Earth gravity. That's fine. But Mars does get a little bit of a help because their gravity's less, right? But we're doing Earth stuff here, but we are going to emphasize that, hey, we're going to try and make our helicopters as light as possible. And we are going to we're going to try to do some autonomous flight as well related to this. So this is the autonomous thing. We don't have a pilot, and Earth will be several light minutes away. So you can't joystick this in real time. Like the transmission time of information going to and from Mars from here is, as they say, depending on what time of the year, but several minutes. So it has to be able to fly the mission on its own. And this is a tricky thing to have it done. It's a tricky controls problem. All right. We'll give you just this has some details as what has actually happened. So Perseverance has been on Mars for a little bit now. This will give you some details as to how that's been and the flights that the helicopter has taken. You'll be able to see some actual data. So that previous video was from before. This is with actual data.
Touchdown confirmed. In the 10 months since the rover has landed, we've been busy, and it's been a year of perseverance. From operating during COVID to the challenges we experienced with sampling to interpreting the scientific results. It's such an appropriate name for the vehicle, but also for the team and the mission itself. This mission has a series of firsts that will help future generations understand more about our solar system. One of my favorite moments was seeing our first rock core sample, looking down the tube when it was still in the drill bit and confirming that it was indeed a success. Now that we've collected samples, everyone wants to know when and how they'll be coming back. We can't wait for the future mission to pick them up and ferry them to Earth to analyze if any of them show signs of ancient life.
The first flight of a powered aircraft to another planet.
Another highlight of this year was working with the helicopter team to deploy Ingenuity and experience the first powered flight on another planet. It was so amazing to see the team adapt to the environmental changes in order to keep flying. The helicopter has become a real asset and partner to our science team. It feels great to be part of making history. What motivates us as engineers and scientists exploring another planet is the opportunity to continuously learn more. Now that we've toured the floor of Jezero Crater, we look forward to investigating the Delta, a part of the crater where a river fed into a lake in the distant past. It's almost as if we're starting a new mission because we'll start to cover new ground and make new scientific discoveries. What I'm most proud of is the team, how we operate the rover, overcome challenges, and the dedication that everyone brings to their job each and every day.
All right.
All right, so we're exploring another planet and we're going to bring back samples. So this is really cool stuff. We're now going to focus on how that relates to what we're doing for this challenge this year. So first, on the day of the challenge, you're getting the stuff today. You're going to work for a few months on this. And then at the end of April, you're going to all meet together. I think it's going to be at Central, Connecticut State University. We're working out the details of that. If we can't get that finalized, it'll be at Quinebaug Valley. I know I have permission to do stuff there, but we're trying to get it more centrally located for that. We're going to have a netting kind of like this. We actually have a freestanding netting that we can set up wherever that's a 20-foot by 20-foot sized and then 10 feet tall. So you're going to have to be able to fly somewhat controlled. But what that's going to consist of is you're going to have 10 minutes to do a presentation to describe some of the stuff, and I'll get into that in a little bit. You'll have 5 minutes to do basic flight demonstrations of capabilities for taking off, clearing obstacles, landing. And then you'll have 10 minutes to demonstrate a bunch of other capabilities for exploring, retrieving samples of different materials, etc. So here's the rubric. I know it's kind of small. It's on the request for proposals. So we're going to go through this in more detail. So if you can't read this right here, that's fine. The main things I wanted to point out with this is that a lot of the stuff on the left is we've got video, poster presentation, weight reduction, rotor protection, camera mount. That's all like design stuff that you're preparing and demonstrating and explaining like how this stuff works. And then from that bottom thing, multi-pilot flight, and then all the stuff on the right, that's all stuff that you're kind of demonstrating on the day of the challenge, right? So there's a bunch of stuff you're doing ahead of time where you're making a poster, you're trying to make sure that you can explain like your design, what went into it, etc. And then the rest of that is like performance on the day, how well can you control your quadcopter and accomplish this specific task. For the presentation, so we're going through the different things you're going to be asked to do. For the presentation, you have 10 minutes. The video is part of that, 2 to 3 minutes on the video. And there'll be a poster. I have an example poster. This is over here. Kind of see if I can show the recording people. Kind of over there. Maybe I can zoom in. On the left there, I don't know. In any case, you're going to have to do a poster. And okay, and then you'll have a chance to explain with your poster and whatever was in the video, but then you'll have a chance to explain to the judges, the people there, how you satisfy those things in the rubric. So you got to look at the rubric, make sure that your presentation is focused and practiced and addressing, like, how did we reduce weight? Well, if there's useful visual aids that would help explain that, you can have physical stuff there, or you can have stuff on your poster. You can have bill of materials on your poster showing the different weights of the parts, how you've optimized things. There are lots of options for that. Is this thing running out of batteries? That way it's not. Okay, no, it's working. And you want to make it easy for the judges to judge, right? You don't, like, they're looking at a rubric and you're trying to see how well did they do this. You need to make it easy for them to determine. For the video portion of that, you got to create your own video. It needs to include a flight demonstration, and it needs to be posted on YouTube. I recommend having some backing music to go along with it, but make sure that you have the copy, like the ability to use that. There's a royalty-free licensed music thing that you can do for YouTube if you're looking for that. You can also look up royalty-free music, but you got to make sure that it's not that you actually have permission to use the music. So don't just put a song that you like. Just because you own the song doesn't mean you can put it in a video that you upload. You need to have a specific synchronization license to use it for that. So that's hard to get and a pain. So the easiest way is just find royalty-free music if you're doing that. If you're trying to edit your video together, has anyone done video editing before? A little bit. What sort of programs do you use? So Final Cut Pro and DaVinci Resolve, those are good options. If you have a Mac, Final Cut Pro is great. iMovie also works. It's not as good, in my opinion. Final Cut Pro costs money. If you are a Quinebaug Valley student, you have access to Adobe products. I think most community college, you can get access in some way, even if it's just at the college. So Adobe Premiere is an option if your college has that. But DaVinci Resolve has a free version that is pretty much as capable as almost anything else you'd find out there. So if you don't know what else to do, DaVinci Resolve, you can install it on your own computers. You can edit videos, overlay subtitles. They're famous for their color correction stuff. So if you really want to do color grading and professional stuff, you can do that. But DaVinci Resolve's great. Yeah, Camtasia. You can also search for like, free video editing stuff and kind of go with that. One thing I'll add on the videos, because I think that's my last thing about videos. Here I'm going to show you an example video that students did. Big thing with videos is making sure that people can see what's going on and hear what's going on. The hearing part has gotten better now that phones have gotten better microphones and that sort of stuff. But when in doubt, like you can record voiceovers and audio separately with a microphone or with like your camera, with your phone in a stationary place where you're talking right to it, so that you get better quality audio. And you want to mix that so that the audio is loud enough and you don't have a whole bunch of extraneous, like if I just put you hear all that sound in the side from like the machine noise, like depending on how you do it, it's really easy to get stuff that just kind of overpowers and makes it really tough to understand. So pay attention to the audio if you can. All right. This challenge is not about making you a professional video producer. So like, don't stress out too much about it, but those are the couple things. So I'm going to show this video for an example. This was not from my college, this was from a different college. And this was one of the better ones that I've seen as far as like, they did some really cool things. You're not expected to be as inventive at this, but yes, please. It is part of the rubric. Yeah, you do get specific points for the video, 10 points for the video. So you do have to have a video and try and make it good. All right. Now, yes, please. You can put whatever license you'd like on that. We require that you upload it to YouTube so that we can link to it. So we would ask that you leave it publicly available on YouTube. I guess we don't require that necessarily, but for the competition, it needs to be uploaded on YouTube. So you can use the standard YouTube license. If you want, you can make it a Creative Commons license. We're not requiring any specific sort of license. The people who make it, so in America, copyright by default belongs to the people who make stuff. You don't have to file for a copyright. When you make a video, the people who make the video have the copyright on the video by default. And we're not requiring that you sign over any of that or anything like that. So if you want to monetize it later and sell it, like, we have no specific prohibitions or restrictions on that. Here are some links to past videos. These are also linked, and I'll take this time to tab on over to the website. So if you go to the Space Grant website, if you go to Events, Community College Quadcopter Challenge, you can see the request for proposals, which has all of this stuff, starting with like why it exists, etc. So I highly recommend you read through this. This has a lot of great information on it. And it has like stuff that's due at the end and whatever, and it has the rubric here as well. So it has the request for proposals, it has sort of the timeline stuff, and then down here, it's got all these different tabs, challenge rules, safety, quadcopter assembly, that kind of go through and give you an idea of how to assemble stuff. I had some students working over the summer trying to put together these resources for you. So the hope is that this is a good resource. If there's something that you think should be added or something that's incorrect or a broken link or whatever, you can let me know or let your advisor know to let me know or whatever, and we can try and fix that and update that. Right now, I think there are a couple of videos that we're going to be linking on here that are not currently linked. So if you look at safety, there should be a thing, insert our video. That video exists. I've got the links to all that, so we'll be uploading those. In any case, I bring it up because if you go to videos, you can click any of these links, and this has links from last year's, so you can look at any of the previous videos. And so that's the hope, is that we would, if you leave it publicly available on YouTube, then we can just leave the link up for future teams to look at. All right, so that's video stuff. Any other questions on videos? It would be really cool if a lot of times, because of the timelines involved, you maybe are only at the very last minute getting sample collection working, but if the timelines work out where you can get videos of your drone collecting water, right, or whatever, that would be really cool to include shots of that. Maybe a shot of your drone collecting water from the onboard video camera, right? There's a lot of cool stuff that just because you're kind of splitting up and having one person work on video and trying to get stuff finalized so it's not all last minute. It hasn't always happened, but it would be really cool to have. And then I would replace that video with whatever your video it is showing cool drone stuff. Anyway, all right, for the poster, answer these questions with your poster. What's the most important thing about my project? How can I get my point across visually? And what can I say about my project that will complement my poster? Don't want to have a ton of text on the poster. You can see the difference between, on the left is sort of a more effective poster. We don't even need to necessarily see the text. We can see key visual things and charts and whatever. Whereas on the right, it's essentially a paper done as a poster, which somebody took their LaTeX file and just exported it as a poster, right? It's too much text. It's too small. People don't want to be reading. That's fine for a paper, but for the poster, you want to have more focus on the graphics. So important information should be readable from about 10 feet away. The title should be short and draw interest. Word count should be somewhat low, and the text should be clear and to the point. Use bullets, numbering, ordered lists, whatever you need to make it easy to read, and graphics, font color, etc. Consistent and clean layout. I'm not saying the poster over there is the world's best poster. It did win an award. The students who made it did win a director's award at the Space Grant Consortium. So congrats to them. But it the design of it doesn't distract from the information being presented. That's the idea. And then an important one, include acknowledgements, names, etc. So the Space Grant logo is available on the Space Grant website. Yes, please. The template is on the Space Grant website as well. Yeah, so if you look on the Space Grant website, there's a poster template. You can make up your own poster template if you prefer, but the logo should be there. The fact that this is funded by the Connecticut Space Grant Consortium, the NASA Connecticut Space Grant Consortium should be on there. Probably your colleagues should be on there. All of your names, your advisors' names, all that good stuff. So again, you can come up and take a closer look at this to see the sorts of things. Again, this was not used to present at a, like you're doing, this was used for a different poster session, but it's an example of a decent poster. All right, so that's the presentation stuff. And one last thing I'll say about this. In the poster, so there are a couple of additional design things where you're going to have to choose a camera and design a camera mount, and you're going to have to design some rotor guards. Including information about that in the video and or the poster, so you have visuals to go along with that, is really useful. So I would include that in there as well. All right, so for actual tasks that you're doing on the day of the challenge, sample return. I didn't include the water. It'll be in a 5-gallon bucket. So look at a standard 5-gallon bucket. That's what it'll be. But then I know there's no water on, like standing water on Mars, but whatever. We're on Earth, so we can pick up water. And then sand and gravel. So this is the sorts of stuff you're going to be picking up, and you're trying to get, it's actually small amounts. So I think if you get some of it, you get some points. And if you get 10 milliliters of water or 10 grams of the other substances, then you get the maximum points you can get for that. So as long as you can get a significant but still small amount of stuff, that counts as sample retrieval. How this works is there'll be an arena. So the 20-foot by 20-foot arena, you can't, like you set your quadcopter down, you can't be inside the arena and you can't be walking around the outside of the arena while you're doing it. You stand in one position outside the arena and you fly the quadcopter and then you fly it back to the edge of the arena to get the stuff, right? So for the sample return, that's how it works, right? You can fiddle with things, and then once you set the quadcopter down, you fly it up, you get the stuff, you bring it back, and then you take the sample stuff. Cool?
Question on that. That's going to be autonomous, or is that going to be manually controlled?
So there's an option for getting additional points for doing it autonomously, right? So I believe it's 5 additional points if you can do autonomous sample return. But yeah, so let me actually just put the rubrics right here. Okay, so for each of the different substances, you can get 5 points. So up to 5 points for water, up to 5 for sand, up to 5 for gravel. And then if you can do an autonomous sample return, you don't have to do this as a separate thing. So if you have an autonomous thing that will go and find the sample and return the sample, then you get another 5 points, which is obviously a much harder problem. But anyway, that's, yes. How many what? It's time. So you have a total of 10 minutes to try doing any of these things, including sample return, photographing, and mapping are the 3 main things that we're doing here. So you have 10 minutes total to do this, and the time's just running. So if you need to switch out stuff in between, whatever, like, yeah, so it'll be mapping the terrain and the thing. So I've got a slide about mapping coming up. So this is sample return. So that's one of the things that you can spend that 10 minutes doing. This is another video. We'll skip this one for right now. For autonomous flight, all right, that's why I had that other video, because it has more about autonomous flight. But anyway, for autonomous flight, what we mean by autonomous is most of this stuff you're able to control using your transmitter, right? But there's a whole bunch of points available for if you can get autonomous flight working. And some of those are fairly simple, like that Ingenuity example of their first flight test of does it work? They didn't try to do anything fancy. They tried taking off, hovering, and landing. And if you can do that autonomously, by which I mean, rather than controlling the rudder yourself, I press one button or trigger the program, however I'm triggering it, and then the quadcopter by itself takes off, hovers, lands. If you can do that, you get 5 points on the autonomous scale. So there are lots of ways of doing that. We can talk about those ways. And then up to like sample return is a very difficult one, autonomous mapping, like you can get more points for all that stuff. But I want to be clear with this. When you're starting to do autonomous things, and anybody who's tried doing like robotic stuff on ground will attest to this, it just does what the program says to do based on what the sensors are having it, which means it can go kind of crazy. So I highly recommend that when you're doing this, and by highly recommend, you need to do one of these two things for sure. You either need to have it tethered by a cable to a weight, so you have some weight that your quadcopter doesn't have enough thrust to pick up, right? So make it heavy enough that it can't pick it up, and it's tethered to it by a cable that is stronger than your quadcopter can exert thrust to break in tension, right? So like have it tethered to that, or it needs to be fully enclosed structure. And some of my students over the summer made some plans for a PVC structure, so you can buy PVC pipes and put them together and get a netting to put over the top with elbow joints and whatever. So I think we'll put some of those sort of plans online on the thing if people want to replicate that instead, so that you don't have the tether maybe influencing how the flight's happening. On the day of the challenge, we will have a fully enclosed structure, so you will be able to try autonomous flight. Since it's fully enclosed in the netting, worst thing that happens is it flies off and gets stuck in the netting. But even with those things, first thing is build the kill switch. You need to have the ability to hit a button to just stop motors running. Because you get in the autonomous flight and it's just executing the autonomous stuff, you need to have an override switch from the beginning that has priority over everything else, that just kills it. I don't know that I assign specific points for that. I mean, if people want to tweak some stuff here, like we can, I just need to make sure that everybody knows about it early enough so that it's not like a surprise to anybody. But yeah. So I guess what I'd say is if you don't have a kill switch, we're not going to let you try autonomous stuff at the day of the challenge. It's just not safe to be able to do, because you can get, even if the thing gets stuck in a place where it's like in the netting, but like it could be stuck partially in the netting. So some motors are stalling out, but then the other motors are kind of making it go up and down because they're just doing their thing, and you can't kill it and you can't approach, because how are you going to, it's dangerous to approach. So we would probably just approach, and I would probably just do it and it would be fine. But we don't want to get in that position. So build the safety first. How you do the autonomous flight, you're going to have to do some research on this. I just want to make sure you're aware of a couple of different ways of doing this. One, there's dead reckoning. What this means is I just try doing things, and I assume that the things that I tried to do happened. Or you can have some sort of feedback control where we look at what happened in response. So, for example, I could spin my motors a certain number of times, right? And then change the speed and spin them a certain number of times and then have them go down, right? Or I could actually look at the accelerometer and gyroscope in the flight controller and try and use that information to know, well, I was supposed to have taken off. Did I actually take off, right? And kind of do some feedback control on that. Feedback control is harder to implement than just like blind instructions, but it's safer and more capable. There's also a robot operating system module thing called Clover. These folks actually did a Kickstarter and then made their own thing, but it's made to work with this open source PX4 firmware, which I probably should have mentioned before doing this. So anyway, we'll get there. If not, I'll pull it up separately. But basically, if you get a Raspberry Pi, what you can do is you can have that Raspberry Pi connected to the rest of your quadcopter, and you can be running your autonomous stuff on the Raspberry Pi. So you can have a way where you start and you can fly it around like normal, and then maybe you bind a switch specifically to flip over to Raspberry Pi control, and then have that execute whatever it's executing. And on the Raspberry Pi, you can interact with that, so that you have a physical Raspberry Pi. It's a type of small computer that is on the quadcopter, and you can interact with that over Wi-Fi or however you're interacting with that to start and stop different programs. And it can get information from the flight sensors and send control information back. So I might recommend that, but there are other options as well. You can write your own firmware. So the firmware is the stuff that's executing on your flight controller that tells it like how fast to spin and things like that. It's open source stuff. You can get into that and modify that firmware and add in a specific thing where you're like, all right, here's my own routine that is going to then interact with that. So there are options there. You can also ignore autonomous flight and put that as a stretch goal and say like, I'm going to focus on this other stuff, and we'll do that if we get to, right? But if you're interested in doing this, I highly recommend assigning at least one, or probably you want somebody who's willing to volunteer since it's going to be a decent amount of work, early on to try and look into this and try and figure out how to get up and going with this. All right, so that's autonomous flight. Now mapping. All right, so you can make a 2D map so you're going to have a camera, you're going to have to figure out the camera, and you can take pictures, and then you can stick them all together into one combined map. Now you can do that manually. So if you want to get a map of the arena, you can fly around the arena, taking video and or individual pictures looking down, and then you can manually open those pictures in Photoshop or something like that, and kind of scale them so that they're similarly scaled, and kind of combine them into one image. That's one way of creating a combined map, right? You can also use software that's made to do this sort of automatically. So in Photoshop, there's a photo merge tool that's made to do this, where if you have multiple photos where some of them are overlapping, then it's made to sort of try and scale them and rotate them so that they kind of mesh together. And you could also write a script, if anybody's interested in messing around with Python scripting or stuff like that, that would take and go through, for example, a video file and pull out every 6th frame or every 1 frame a second or something, so that you have your video, it pulls out all the frames for you, sends it through one of these automated tools. So there are lots of options as far as like, okay, we can do this, but it takes us hours to do, but we've demonstrated that we can do this. Or I've got something where I can take, on the day of the challenge, that video or still images, and I can make a map and show it to the judges right there on that same day. Those are different levels of complications and difficulty, right? So there are points for being able to show ahead of time, like on your poster or whatever, like demonstrate that, hey, we do have this capability to reconstruct maps, versus if you can show it on the day of the challenge from the live challenge arena, then you get more points for that. There's also 3D mapping. And then like finding the actual scale. So one easy way to get actual scale is if you have some object that you can take the scale from and just make sure that it gets scaled appropriately to that. But having your map scaled is good. 3D maps. Photogrammetry is probably the way you'd want to go if you look into trying to make 3D maps. This can be a little bit tricky. There used to be some other good free options. Some of that's gone proprietary. There are great options here, because this is a thing a lot of people want to do for video games, for lots of things, for making 3D reconstructions when you have a lot of photos. So Autodesk Recap does this, Drone Deploy does this, Pix4D does this. A lot of those are very expensive. We don't necessarily have money to pay for you to have access to those commercial softwares. If you have access through your campus to, for example, Autodesk products, and you happen to have access to Recap, you're allowed to use that, right? So use what you have access to. But there are open source photogrammetry options as well. They're a little bit fiddlier. So I, for example, have not messed around with Open Drone Map, but I know it exists. So what these photogrammetry things do is they take 2D images, and some of them can incorporate positional data like you can get from your flight controller sensors. And they find common points, and they stitch them together, and then try and reconstruct 3D surfaces. So that's a little more complicated. These generally take hours to run. That's hard to do live on the day, but you can do that ahead of time. You can also do live 3D models here. I'm including a link to a presentation by Skydio, who's a company that's working on doing this. If you saw, there's a thing called simultaneous localization and mapping SLAM. That's very difficult to do with the computational power that would be available to you, that you can fit onto a quadcopter in the weight and that sort of thing, right? But if you have, I have tried doing it, and it worked to some definition of worked, in that I couldn't actually do it live while I was flying, but I could get data. So this was a Kinect, took apart and got the RGBD, so it's a camera that then has depth information. And then I was using an XU4, Odroid XU4, and this was, I've just put it on some things to kind of isolate it from vibrations, and I've laser cut a custom mounting plate that then interfaces with this, so it can kind of mount on there. And I had these things connected and was able to fly around and get data, and I never got it working as well as I had hoped. So, but it would be really cool if one of you could get something like that working. The actual sensors that you need something that can get like generally distance information as well, and those can get kind of expensive. So I'd be curious to see what people can come up with. I'm just giving you ahead of time. This is one of those like stretch things, like, man, if you can do this, that'd be really cool, but it's going to be probably pretty tricky. That video is like an hour long, so if you're thinking about considering this, I would watch that video to get an idea of the current state of where things are. All right. So that's yes. So for all of this stuff, for mapping, you can control the drone while you do this. There are additional points for if you can do the autonomous mapping. Yeah, so it'll be a 20-foot by 20-foot arena. So the size of the arena that we're looking at, that you're going to be flying over for the day of the challenge, 10-foot tall ceiling, 20-foot by 20-foot footprint square. So square. So it's 20 feet by 20 feet square.
Okay, so basically we can use the dimension. Like if it like gets up from here, it has to go 25 in each direction, and then like throw the thing or something.
Yeah, exactly. So you can say, like, from where I start, I'll go, you know, you can do some test runs and figure out, okay, if I'm looking down with my camera, I need to be 5 feet tall. How far does my camera shoot? So then I can describe a path that I'm going to try and follow that stays on the inside boundaries, that then sees the entire arena and gets all the pictures I need. And you know, depending on what you get for your camera, you can maybe even tell it to take pictures at specific times or whatever, right? There are options there. Other questions on mapping? All right. So it's probably worth just going over some quadcopter basics. So who here knows or can describe maybe quickly how like a normal helicopter works? Like, how does it fly? How do you? Yes, please. What's your name? Gus, please. Yeah, kind of like a fan, right? So spinning the rotors, and they're angled. I'm just repeating so everyone can hear. And so then they shove air down, and then that Newton's third law, equal and opposite forces, you're pushing stuff down, so then you have the force pushing back up on you upwards, and so you move up from that, right? Now, does anyone here know the term torque? Torque, right. So if I'm spinning my blade in a certain direction, then I get a certain amount of torque that's trying to, like it's making stuff spin. So if you just have a single set of rotors and you spin it, then your helicopter is going to want to spin as well. And so that's one of the reasons you have the tail thing, and other is to reposition and angle and whatever, and stability. But what part of it is to counteract that torque so you can kind of have more stability. So quadcopters, how they work is you actually have 4 rotors, and you have equal amounts counterclockwise and clockwise, so that you don't end up with the the machine itself wanting to spin because those torques kind of cancel each other out. So then how do you move forward or back or whatever? Well, you have to spin them at different rates. So you could imagine yourself with like 4 levers controlling each of those rotors separately and just sending different amounts of voltage to them. But that's going to be very hard to keep that all in balance in the amount of time, like human reaction times, to keep everything balanced and to move forward and back and whatever. So what we do is we abstract away from that and we allow some electronic speed controllers. So on here I don't have the rotors on, but like we've got motors, and those got motors, and then you've got electronic speed controllers that send the actual current to power these electric motors, right? And they determine from the signals they're getting in from the brain, from the flight controller, how much to make those spin. And so the flight controller, we tell it, okay, I want to go forward, and then it uses its brain to figure out what signals do I send to these speed controllers, which then send along the actual power to the motors. So that's the basics of how this works. So rather than controlling each independently, we can just send some more general signals, but then the flight controller figures out how to turn that into actual voltage that ends up at the motors. So far, so good? So one thing is that the net thrust from this, each of these is trying to thrust upward. So if you're trying to then go forward, you kind of tilt to one side, and then you end up at an angle. And now the amount of thrust you need, since you're still having to balance your weight, which is still going straight down, if you have the exact same amount of thrust that was holding you level in air, and then you turn it sideways, you're going to have less thrust going upward. So your natural thing, if you're using sort of naive controls, is, okay, I tilt my quadcopter so I start going this way, but now since there's less going up, it's going to start dropping. So as you tilt over, you end up having to increase the thrust to keep it at a constant elevation. And a lot of those details can be taken care of by the firmware that's running on the flight controller. So that rather than having to manually adjust all of that stuff, which is what you do if you're doing like acrobatic stuff, if you're just trying to get level plane, level flight, you can use stuff in the flight controller so it can figure out, okay, I'm going forward, and then it increases the thrust as it needs to in order to keep you at the level height. All right, so that's like basics. There's sort of broken out. And here's the block diagram of the quadcopter you're going to be putting together. So basic idea is you start with the transmitter down at the bottom. I don't know if I have a light or something, but start with the transmitter down at the bottom. So that's the thing you're holding on, it's sending out signals. So it sends signals to a receiver. Then the receiver is plugged into your flight controller, and now the flight controller knows what to do. The flight controller then sends out here on this PWM out, it sends out information to the speed controllers, to the motors, and then it does the stuff. So that's the basics of flying that stuff. Now, to get power to all this, power with the battery, you need a power module so that you can take some power from that battery through the base plate, so you have your high current stuff that goes to the speed controllers. And then some of that power you send to the brain so that the brain can do its thinking, right? So the flight controller can think. So that's why you need the power module to split that up. We don't have power modules for you today. They're on order. They were supposed to have arrived with the flight controllers. They haven't yet. There's been, shipping stuff. So as of right now, with the stuff you have in your boxes, you can't put this together because you're missing this part right here. Once that comes in, we'll send it along to you, and then you'll be able to do that. But what you can do is you can understand a lot of this other stuff, and you can, for example, solder on the electronic speed controllers onto the base plates. You can try and connect up a lot of this other stuff. You just can't solder the main power module ends onto theirs as of right now, just because physically don't have it. Everything else you can do. Some other things I'll mention. If you're flying outdoors, for this competition, we're not doing GPS. We're doing indoors. We're doing, if you're on Mars, there's no GPS, so we're not doing that. But for most Earth applications where GPS is a common thing, GPS is really nice, so you can plug in GPS. And then telemetry. So telemetry, you can have a telemetry unit that you plug in at your computer, and I think that's also not here. I'll double check on whether that's on order or not, or whether you would have to choose to order a telemetry unit. The nice thing about this is this basically you can think about it as a thing that phones home back to whatever it's connected to. So it always has whatever information it has there, but if you want to have, for example, your accelerometer data and you want to look at it live while it's flying, you can have that telemetry unit sending it back to your computer and you can be looking at that on your computer. So this gives you a way of sending information from the quadcopter in flight back to something else. So it's kind of like Ingenuity. It's sending its information from flight back to the Perseverance rover. It's not connected to any of the things outside of Mars because it doesn't have that much power, but it's phoning home back to the rover. So
The GPS?
Yeah.
So is that optional? Or?
Yeah, it's optional. We don't really need it for anything we're doing. If you're flying outside for some of your stuff, like say you want to be able to demonstrate mapping from other stuff, like having your GPS to be able to control waypoints and do that, it's cool to get that set up. For any sort of commercial application on Earth, most of the time you're using GPS for most of that stuff. All right, so that's like how this stuff works. All right, I've got a couple more things. So we've got making sure we understand how batteries work, and then I think it's cameras, and then that's most of it. How are we doing so far? All right, we're gonna press forward. So batteries. People have used batteries before. Now, there's some interesting stuff that's worth knowing when it comes to these sorts of like radio-controlled stuff, batteries. So one thing is having the basic concepts of what voltage is. So voltage is like water pressure that's putting water down a pipe. So this helps if you know about water. If you don't know about water, then this doesn't help you so much, right? But you can imagine if you have a tub, when the tub's full, it drains really fast. When the tub is close to empty, it drains less fast because there's less pressure there. So that's what voltage is. It's like how much is trying to push through this. Resistance is like the size of the pipe. So you can imagine you got a gallon of water or a gallon of milk or whatever, you poke a tiny hole that's very small, so not a whole lot of stuff can flow through that. Maybe it'll come through it pretty fast, but it'll be a tiny little hole. You're not going to get a whole lot of volumetric flow through that. Whereas if you punch a bigger hole, now more milk can come out, right? So resistance is the size of the pipe. Now this is important when it comes to wires. So this right here is some kind of thick, what is this? 14 gauge wire. So if you look on the inside of this is pretty thick. If you look at other wires, like these tiny wires, like this, the center of this wire is thicker than even the shielding on these tiny wires. Some of these wires are very small. Anything that's doing high current, you need to have thick wires. Anything that's doing just low current, like sending information around, generally you don't need as thick wires. But anything that's sending like a lot of power, you want thick wires so they don't burn out. All right, so that's resistance. So bigger wires have less resistance, so you can send more stuff through them. And then current is how much water is coming out, or how much, electrical current is flowing. So power is how hard the water is coming out of the pipe. So the amount of electrical power you get is a combination of the pressure, or the voltage, and the current. So if you do voltage times current, that gives you the power. Now our voltage for our batteries, let's look at, you pull out some batteries. Let's just grab. Oh, here it is. Yeah, here it is. All right. So we've got some batteries. So these batteries say on them, it says 120C. I'll get to that in just a little bit. 11.1 volts. So the amount of voltage you have is set by the electrochemical cell. So you got different chemicals in here. And based on that reaction, you're going to get a certain amount of voltage. Here, you actually take a couple of, well, it's 3 of them together to get that amount of voltage. So the actual cell is like 3.7. All right. Oh, here's an example. I was smart. I put something up here so we can all see. All right. So this says 3S, 11.1 volts, 2200 milliamp hours. What do those mean? All right. So the voltage per cell, the nominal voltage, that's like what's it listed at, kind of like a 2x4 nominal, it's 2 by 4 inches, right? So 3.7 volts. When this is fully charged, it's actually higher voltage than that. When it's fully charged, it can get up to 4.2 volts. The minimum safe charge is 3 volts. You never want to discharge it below that. It starts damaging the battery. So on your quadcopters, they'll generally be, the firmware you're using will have some sort of low voltage indicator, and you'll have a chance to set that up. So it should warn you when you're getting below a certain threshold, because you don't want to run the battery that hard. It stops working as well. It's no good. 3S means that you have 3 cells connected in series so that you add those voltage together. So the 3.7 volts times 3, like you add 3.7 plus 3.7 plus 3.7, that gets you the 11.1 volt. And then capacity is how much energy it can store. So that 2200 milliamp hours is capacity. And you can estimate your flight time with, if I know my average amperage draw, I can take that capacity, divide it by the average amperage draw, and that gets me the flight time. That's why it's in milliamp hours, because it lets you do that. If I know how many milliamps I'm drawing, I can divide that out and figure out how many hours it's going to work for. It kind of makes more sense to me to put it in joules. So if you don't know it, does anyone know joules, unit of energy? If you don't, that's fine. But the capacity, it's how much energy is stored. So you can think about it as joules. Here, the units are milliamp hours just because it's sometimes useful to do that. But anyway. Your discharge rating is how fast you can discharge the battery safely. This is very important. The batteries we got you are like 120 C. So you can really draw on those things, right? So you multiply that by the capacity in amps. So here, if my capacity in amps was 2.2 amp hours, I multiply 2.2 amps by 30, because this was 30 C, and then I get 66 amps. So for this battery, let's see what are the numbers, and let's do the calculation. All right, so you say so it was 24.42 watt hours, which is roughly the same like as that one, right? So we'll just say it's, yeah. Anyway, you can do that multiplication. It doesn't have the milliamp hours to do it exactly the same. But,
2000 milliamp hours on this one.
oh, it says that? Okay. All right. So you've got your 2200 milliamp hours. That's 2.2. Multiply that by 120. That gets you what? 240 some odd? 264. So you can really draw those things. It's going to be hard to draw more current from those than you can. So those should be all right. I have some other batteries here that we can also hand out. These ones, just to be able to have them, are 3700. So they're a little bit bigger, so you can fly for longer, although they are heavier. These are 25C. Now, 25 times 3.7, you should still be able to draw enough current from them, so it should be all right. They have a different connector here, but we have adapters for that. So I can hand these out as well, make sure everybody gets one, but I just want you to be aware of when you're looking at batteries, you can just plug stuff in and see if it works, but in general, given that these things can catch on fire and stuff, like it's from drawing them too hard, that's generally not going to happen, but it's worth noting. Our old one had other stuff, but we have different, I didn't have the modern, like the exact information of what speed controllers we would have here for you today. I think we have 30 amp speed controllers. So the 30 amp speed controller, electronic speed controller, is not going to draw more than 30 amps. You can do the math and make sure that we're not going to draw more than the batteries can provide. So it should be fine. We kind of did that for you So you're not having to design this from scratch, but anyway. When using LiPo batteries, pick it up by the body, not by the leads. Charge it in a fire-safe bag if you leave it unattended, and really don't leave it unattended. Like, leave it attended. And you want to, don't charge them if they're hot. Don't charge them if they're swollen. If they start swelling, just stop using them and set your balance charger correctly. So the balance charger is, we got you this one. Switch this to full screen. So we got you this one, which is whatever it's called. Anyway, it's a balance charger. You're like, all I'm trying to do is charge a battery. How hard can it be? Well, for these things, because we're pushing them kind of hard, we're trying to draw a lot of amperage from them, a lot of current to run these things. What you want is you want to have each of the cells, I told you we have 3 cells, we want them to be balanced, right? So we don't, if you were to just hook this up and be like, all right, so it's 11.1 volts. So, and then when it's full, it's 4.2 volts. So I just charge it up until it's what, 12.6, and then just plug it in to 12.6 volts, just connect it to a 12.6 volt battery or whatever and let it charge up. And then your battery ends up 12.6 volts, it's full, right? Problem is there's 3 separate cells. So you could have one cell that's over 4.2 and one cell that's under 4.2. And now when you try and pull on them, now they don't deplete even, right? So the balance charger, what it does is it charges it up, and your batteries have a separate thing that needs to be plugged into the balance charger that, depending on how many cells, this will have fewer or more. So like this is a 3 cell, so there are 4 pips here. If it were a 4 cell, there'd be 5 pips. You plug that into the appropriate thing on the balance charger so it can read the individual voltage of the cells. And then what it does is, as it's charging it, it discharges and recharges the other one. So if one's getting too high, it discharges it and charges it into the other one so it stays balanced. And what that means is that when you're running it, it'll actually work. Otherwise, I had students, before I told people about, I mean, I'm not trying to throw anybody under the bus. You folks are learning, you don't know, right? Why should you know, right? But people would just plug it into something and charge it up, and then the batteries would die super fast. And it's like, why is this happening? Like, no, you got to use balance chargers. So you have balance chargers, but just giving you balance chargers and batteries, people still sometimes just plug it in. So make sure you know how to use them and how to plug in. Both things should be plugged in while you're charging it so that you can charge it appropriately. There are manuals. It should be doable. Cool? All right. So that's stuff on the ground. Yeah, so I think only, yeah, so if we only had 3 so far, I think more coming. So this is just a battery, it's a fireproof thing so that if the battery catches on fire, you're okay. So recommendation is to charge it in here. I'm not responsible if you burn stuff down. In general, if your battery is working well and you charge it, it's fine. The balance charger should work. But for extra safety, and because different people have different levels of risk tolerance, don't leave them unattended. Make sure that somebody's in the room. You don't have to be like constantly watching it. But if you're in the room and it's in the bag, then worst thing that happens is it catches on fire, and then the bag contains the fire, and you're fine. I've never had, in all the years doing this, anybody report catching one of their batteries on fire from doing this. The way that tends to happen is if you have a swollen battery, or it's hot, and swollen, and then you start charging it and putting energy into this thing that's not, it shouldn't be swelling. If it's swollen, like start puffing out, just stop using it. It's dead. You're done with it. So. Now, the safest charge rate is 1C, or 1 times the capacity of the battery in amps. So for 2200 milliamp hours, what's the safe charge rate then? Sorry, what's that? Yep. Or if you're setting your charger, it'll give you a thing to set in amps. So I guess I didn't tell you the conversion between milliamps and amps. It's 1,000 to 1. So if you have 2200 milliamp, that's equal to 2.2 amps. So you take your 2200 milliamp hours, that's 2.2 amp hours. That means that the safe charge rate is 2.2 amps. If you're not in a hurry, you can just charge it at 1 amp. It's fine. It gets charged. 1 amp is still a lot of current. But if you're trying to recharge it, like what I'm saying is don't charge it faster than that. It drastically reduces the lifespan of the battery. And if you go too high, then it's bad. All right, so that's the, like whenever you have energy stored, and it can be dangerous, so there you go. What else? Flying safely. When flying, we gave everybody safety glasses here. So wear safety glasses. You've got stuff spinning really fast. All it takes is a tiny chip, or your thing crashes and kicks up some dirt into your eye, and it can cause abrasions. Like it's no good. So, yes.
There are safety glasses for your entire team in each band. I would suggest marking yours so that you're all set. We've got markers here if you want to do that.
All right, rotor guards. So we provided rotor guards. Sorry for grabbing all your stuff. We actually gave each team 2 sets of these rotor guards. Now you're designing your own as well. So part of the challenge is you're designing your own camera mount and you're designing your own rotor guards. But so that you could fly, but like maybe you're working on designing rotor guards or you're trying to 3D print some rotor guards and it's taking some time, you can at least have rotor guards to have in the meantime. Generally, people when they're flying outside away from everything don't necessarily need the rotor guards, but I'm telling you, just use them anyway. Inside on the day of the challenge, you're going to have to be flying with rotor guards. So the only reason sometimes people flying outside don't like them, or the main reason, is because it can catch wind more, right? So depending on what your rotor guard is, can catch the wind. Inside, the challenge will be inside. There will be no wind, so you won't have to worry about that. So these are just pre-made ones that can kind of snap on. You can design yours to bolt on, to snap on. There are a lot of ways of attaching it to here. So it could attach to this edge like these do. It could attach someplace back here and kind of extend out. There's options for designing your own rotor guards, but you have these so that you can fly before having your own rotor guards designed. Stay a safe distance away and don't fly over people. For autonomous temps, either have a cord attached or be fully enclosed by nets and then be ready to kill the power. Those are the basics of being safe. I guess I'd add, if you're flying inside, I've definitely gouged walls and things like that, even with rotor guards, because I fly and then I hit something hard enough to break it. And so use your best judgment on that. I've had my students fly indoors and generally not do a ton of damage to things. Request permission to use our gym, and then we use it while other people are not in the gym, so that there's, just in case. And then everybody's wearing their safety glasses, and we just try and stay away from the walls, and it's generally been okay. We put mats down or things down on the floor to try and keep, like, in case it crashes, that we're not wrecking because we're flying in a gym, right? But a lot of our stuff that we've done has been outside as well, just while we're practicing. Yeah. So that's safe flying. Yes.
Even these challenges we have when we flow at Quarterback and other places, when these things crash, these pieces fly all over and they come through the net. So please wear your glasses.
Yeah. It's one of those things that it's a low percentage chance, but with the glasses on, it's essentially zero, right? That like as long as I'm wearing the glasses, like your eyes are just. If a piece flies off and you get some freak accident and then you get like a small nick here from something flying at you from 20 feet away, like your skin will be fine. But if that same thing happens to your eye, it might not be. So you only got 2 eyes. You need them both for depth perception. So, all right. So that's flying safely. This is flying legally. Flying inside is always fine. If you have your own place inside, nobody's going to care. FAA doesn't care. You're fine. So if you're flying inside, you don't have to do anything. But for flying outside, what you have to do, you have to pass the trust, which stands for something. Click on it. It's knowledge test, I don't know. AU is for autonomous, I don't know. You look it up. But it's a free online exam. The first part presents information. The second part, you answer questions. You can't really fail it. You just go back and redo the questions. But you have to do this. You put in your name. You get a certificate. You print out that certificate, and anytime you're flying outside, you have that certificate. Never been a problem, but if somebody were to come and, I don't know, you crash into somebody's Lamborghini who's a jerk and wants to blah, 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 you'd be like, hey, we were taking our best precautions. It was a freak accident, like whatever, right? So I've never even had anybody ask people for, oh, do you have this stuff? But officially, these are the rules. So do what the rules are and you're fine. So get the trust thing, have the piece of paper, have it with you because you're officially required to supply it if somebody asks you to show that you have it. Register your drone and label the drone. The labeling, this is pretty cheap. The labeling, I've had people laser cut it onto here to be cool, but you can just write it with a Sharpie or you can put a piece of paper on it so that it's labeled. So it needs, if you're flying outside, you got to do that. For the trust, honestly, I think it doesn't hurt for everybody to do the trust. I would just recommend that they all do it just to do it. It's not hard. It's not long. For the registration, you only need one person to register the drone. Technically, I believe they're supposed to be there whenever it's flown. Double check on that. But yeah. And then follow the safety guidelines. There are additional safety guidelines that tell you essentially what I said before, don't fly over people. Blah, blah, blah. I think for legally flying, if you want to check you're in a restricted airspace, maybe I'm too close to an airplane, there's this Before You Fly app that you can check on that. If you're outside of those restricted airspaces, so you're called uncontrolled or Class G airspace, just stay below 400 feet. If you stay below the tree line, you're generally fine anyway, because planes are not flying below trees. But 400 feet, if you're trying to go above the tree line, stay below 400 feet. If you're in uncontrolled airspace, that should be fine. Again, you check before you fly to tell whether you're in Class G or not. Don't fly in controlled airspace. Just don't do it. You can ask if you're near an airport, because there are some of these small airports that you might be near. Generally, what they'll tell you is, well, we can't tell you yes because our lawyers don't want us to ever say yes that you can fly near us. But like they don't have flights coming in or out. But if you stay below the tree line, then you're not going to hit anything anyway, so it's fine. So keep your drone within your line of sight. Don't fly over groups of people. Know the rules, follow the rules. I'll add for recreational flyers. You folks are flying as a recreational flyer. Just a second, I need water. What that means is you can't do anything useful. If you want to do anything useful, you need Part 107 clearance. You can look online and find that. It's pretty easy to know how to do that, but it's more involved to actually do that. The test is more involved. I think you might have to pay for that test in general. But Part 107 is useful if you ever want to do this professionally. So even if you're not running a drone business, maybe you're working for a company and they want you to be able to like inspect some bridges, right? Or whatever it is you're doing. You're doing anything useful, there's also other additional, like more complicated commercial licenses, depending on what sort of things you're doing. But for simple things with relatively small drones, Part 107 works for most of that stuff. But I want to be clear, this recreational flyers, it doesn't mean non-commercial. It means recreational. So if, for example, you're working at an educational institution, or you're helping out a local nonprofit, like I've got a Chamberlain Mill organization that's trying to restore this old mill, I can't do a flyover and make a nice video for them, even though they're nonprofit, because that's somewhat useful that they can use to promote their nonprofit for their mill that they're trying to do as a museum. Technically, that's not allowed. In practice, people do this stuff all the time. But you're not allowed to do that without Part 107 clearance as of, I believe it was last April, or no, 2 Aprils ago or something. So just know that. So like if, for example, I wanted to go and survey a coastline and map out a coastline, I could do that because I'm doing that for my own enjoyment. if I were then give it to a nonprofit that was trying to like clean up the coastline so that they could figure out, hey, where's their trash? Let's go and find that. All of a sudden, it becomes non-recreational use. It's not a commercial use, but it's non-recreational. Do with that information what you will, but I just don't want you getting in trouble somehow tortuously from like, oh, you've got this drone, and now your college is like, oh, we could have you make a promotional video for our college to promote our college as a thing and whatever. It's like, so we're having you make a video, we're having you do stuff for this competition, but none of this is like useful to us in any way. We're not publishing papers on this. We're not doing anything useful with this. We're doing this purely so you can learn how to do this. So I've crossed all my T's and dotted all my I's. We're legal, okay? It's okay. Getting Part 107 is a pain. So do it if you want, though, and then you can market yourself to companies and be like, hey, I can fly for you if you need me to. And you can fly like more expensive drones that are like nicer made, that are easier to fly and work better and have a lot of the stuff built in as opposed to our hobbyist stuff that we're building ourselves. So. All right, I think I've covered all that stuff. So last sort of thing that I wanted to cover was for this, we're leaving you we've bought a lot of this stuff for you. We've designed stuff that we know works together and you should be able to get it up and working. But we're leaving a little bit of design space specifically in the camera. We haven't bought you a camera. You're going to have to do some research and figure out what camera to get. Now, I have brought a couple of cameras here that past teams have used. This is a GoPro. Let me, for the recording, switch back to this. This is a GoPro something. Hero 4 Session, whatever. So this is one that a past team has used. If people want to pass that around, just make sure it gets back to me. You can kind of see that there's this one. This is a run cam. The run cams are a little bit less expensive. So this, if you'll notice, has, so it's a camera, and then it's got this to plug in here, and then these, which can be plugged in to like quadcopter stuff, right? So some cameras, like the GoPro, is kind of a standalone. It did its own thing. We didn't interface with the flight controller at all. It was set up, and they controlled it by an app on their phone, so they could take pictures and start recording, stop recording, but it was a completely separate system from the drone. Like the drone was doing its thing, the GoPro is doing its thing, no talking. Some cameras, especially if you're looking for FPV cams or FPV that can interact with flight controllers, you can get ones that you can plug in and maybe control with the flight controller and maybe start recording, stop recording with that. And then this, so if people want to, I'll pass this around in here so people can see, and then you can plug it in separately to get data off of it or whatever. Some of them will have Wi-Fi connection. So like the GoPro, you had the Wi-Fi connection already set up. What are some other options? This one, okay, so this is just a different flight controller in here. So this is a PixHawk. You're using a Pix Racer. This is an older one. It's not as good. These things in here tended to break a little bit. Wasn't my favorite. But also in this box, and be careful with it when you handle it, is this buddy. This is a PX4 Flow smart camera. And so this one doesn't have a very good resolution. This is only black and white. For getting nice color photos, it's not what you want. But this was made to interact with PX4 on a flight controller. And the idea is you look down and it looks at stuff on the ground, and then you can use that to control your position. So this is like a feedback thing where you can like, okay, I am over the thing I want to be over, right? You can also use it to get pictures and whatever, but it's not going to be as good. And getting this set up is a little bit of a pain, but I have successfully done it. I've also successfully laser cut a custom plate to mount it on here and whatever. So, and this right here, I believe, is just a rangefinder, so you can tell how far away the thing is. I think ultrasonic or something to tell how far away the ground is on that one. But then you've got the sensor that then makes it easier to hold position in the air over a specific sensor. So there's this one. Again, be gentle with these as we pass them around. All these parts. So I'll talk about that in just a second. So, and then here, this one is an Picasso something or other. You can look at it. And this one has replaceable batteries so that you can swap out the battery. Instead of having to recharge the battery on this thing, you can swap it out. So that was a nice thing about this one. And then there's this other one that a student was like, we should get this because it's a really good, and it's way cheaper than these other things. And I use it for like my camera and my dash cam for my car. But then like powering it was a pain and it ended up not working out so well. But that's what this one is. It's a, there you go. It's a dash cam for a car that people decided to try and make work. Boblov or something. So you can take a look at those two in there. The Boblov didn't work out so well. The rest of these worked, for some definition of working, right? Depending on what you're trying to do with it. So you have to decide what camera you want to use. And for the cameras, where's my... Oh, there's a $250 limit. So this $250 limit is for cameras and for anything else that you need to get from us. So if you're trying to get a Raspberry Pi and you want us to pay for that, we can do that. We can order you a Raspberry Pi if you're trying to use that for Clover. We can order you the cables to connect it. Like, we can get that stuff. But that's all out of that $250 limit. So this is going to be one of the first things you're going to want to do. February 11th is the deadline for this. You can send stuff in earlier if you want us to try and order stuff earlier. We can try doing that. Keep in mind, who knows with Omicron stuff on supply chain, how much stuff is going. So, we're doing the best we can. This February 11th is way in advance of April 29th. But if something's says out of stock, don't assume that it'll get back in stock in time. Try and find something that is in stock at the time where we're ordering it, and we'll try and get it ordered. And we're cutting you off at February 11th. It's not a super, I don't know. We can be as strict as that cutoff as we'd like, but basically, we don't want to get in a position where people are asking us to buy something in March, and then it's not going to arrive in time, and whatever. So
faculty mentors, you can do this two ways. You can ask me to order it for you. Then I can have it shipped directly to you. Or you can order everything yourself and then send me a detailed invoice. And I will then pay your school.
So faculty advisors, I'm just repeating for the recording just in case. For ordering this, if you want us to order it, you can send us the information, and we do need the faculty advisor to send it to make sure that everybody's on the same page with that. And we can order it for you, or you can order it, send the detailed invoice, and get it reimbursed through your school. So if you have the ability to send the purchase rec through your college or whatever, that might be the easiest, just depending. But you can also send it straight through here. So one of those two ways, you can do either way. So I guess the advantage of ordering it yourself is you can make your deadline whatever your deadline is, and just make sure that it gets done in time. But I highly recommend, don't put in. You should be able to do the research and figure out what camera you want to go with. Honestly, within a week, probably, right? But, we're giving you through February 11th to get through the start of classes and that sort of thing. And then, but do this early. Yes? All right, cool. And spending less for the same performance is good. So don't feel like you need to spend all 250. Don't feel like it's bad if you spend all spend the money you got to spend, but anyway. Just like with anything, yeah. Now, I'll mention it here even though it's not on the slide. All this stuff, there's going to be some breakage on this. Like your rotors, you're probably going to break some propellers, right? Some rotors. A lot of this stuff, though, like the flight controller, it's kind of expensive. And if it's sort of centrally located, it's kind of harder to break. Like if it's in there, it's mostly protected. You can stall out motors. We have some replacement parts if we need to for some of that. Like I've got some extra motors at QV that I can send around if people stall stuff out. If you have money, one way I've used for just random miscellaneous stuff is if there's a robotics club or you've got student activities, you can start up a quadcopter club or a robotics club or a STEM club or something like that. You can sometimes get student activity money to pay for some miscellaneous stuff. And that gets you stuff that you can just live at your school. For these things, the expectation is for the cameras and for the quadcopter stuff, you're bringing all that back on the day of the challenge with these bins so that we can take that and try and reuse stuff for next year as well. I know some stuff is going to break. You're flying things are going to break, right? But as best you can, don't feel bad if stuff breaks. But my point is that we're trying to recollect the stuff so that we can reuse it. So if people want to use similar cameras next year, we can just hand back out cameras, or they can choose new cameras, right? Like we're fine with having a little bit of a stock on. So everybody's clear, doing the stuff, and you're turning it back in at the end. All right, I have questions here. I left off one thing that I probably should have had a slide for. And that thing is your deliverables are here somewhere. All right, so design, build, and practice. I say do the things. So this is, a lot of similar information to what I just went over. But then the day of the challenge, show you a video. After the challenge, here you go. So each student, after the challenge is done, has to submit a direct participant report form. Similar to the forms you've done before, there's a link there. You have to submit a post-survey of skills, and they're available online. And then the faculty advisor must submit a higher education report. So that's after the challenge, right? So before we can get your stipends or whatever, we got to do that. And then the last thing, here you go, is that there is a final report as well. Now, the idea isn't to make this a super onerous report, but there will be a way to submit it online. And with this report, this should include the link to the final video. There'll be a place to submit your poster. So we have an electronic version of your poster as well. So you print out your poster and have it there on the day, but then we'll have an electronic version as well. So this stuff is all like getting ready for that challenge. We're trying to have all that done for the challenge so that on the day of that challenge, all that stuff is already done. So after the challenge, all you got to do is fill out some like post survey. Oh, do I have experience with these things that like you did that pre-survey? Now we got a post survey and you'd be like, hey, these people learned some things. They did some stuff. Success, right? So hopefully after the challenge, there's not a whole lot of loose ends to tie up is the hope. And that's about it.
I have a couple of things.
Okay.
So we're taking photos today and we're going to post them on our website. Nothing requires us to have a media release for you. So if you could please sign that and then please select them. So whatever we put on the website or social media will be above board. This week, well, like next week, our spring call for applications, if anybody wants to apply for a grant of some kind, scholarship, project grant, undergraduate research fellowship, anything like that, please do so. There's faculty grants as well. So, and then we have some data and stuff that we can give out to you later, and we have lunch. So,
Where is the grant information?
all on our website.
Okay, gotcha.
Right. We have a new system that's going to go live either today or Tuesday. We're not.
Will this video be
Yeah, so the plan is that we'll post this video on YouTube and we'll include the link on the main Quadcopter Challenge website is the plan. So you might be watching this right now on the Space Grant website. I'll show you, it's here. So you go to the Space Grant website under events, you go to Community College Quadcopter Challenge. And then if you scroll down on this first thing, we say add rule video, like this going over what's going on. We should just have a link to the YouTube video right down there from what happened today. So. Yes, so the question is, what's the incentive to do well? Well, aside from your inherent desire to, oh, it's a rubric. Okay, so the actual rubric, here you go. The rubric is on this thing. And the incentive to do well is that there will be a plaque. I'll confirm with them as well, but there'll be a plaque for the first place overall team. And I believe we'll try and get some certificates for specific categories. So for example, I definitely want to have for like automation, like an autonomous category, like winner of the autonomous category. So even if like there's a first place overall, but then there would be for specific categories, some certificates as well. So I have to talk to them about making sure we can do that. And that way you can brag to everybody about, hey, we were first place in the mapping or whatever it is. The autonomous, presuming that anybody can get any points in that, then I want to be able to give a certificate to whoever got the most points in that category. So we might have that for all of these subcategories for like best video certificate, best, so we'll see on that, so that there's a variety of things for that. So that's sort of the incentive. You can brag about that on your transfer applications, on whatever, like, hey, I did this quadcopter challenge team, I put together a quadcopter, designed these modifications to it, and we placed first in whatever this category is, if you manage to get that. So that's your incentive to try and do well.
NASA logo, or we like to use the NASA logo at our school to kind of promote that we're doing this?
I think so. We have the Connecticut Space Grant Consortium logo that you're absolutely allowed to use.
I'll send something out, since a special one that we have to use, it's with NASA partner. So, send that.
Thank you.
Yeah. As far as what's in these, we can spend some time if people want going through and making sure you know what these different things are, or you can just take them. But I did want to mention one thing. I know I'm using your folks for everything. I appreciate it. Thanks. So we also have these here. So this is sort of a self-contained drone. So while you're working on getting some things designed, getting your camera ordered, waiting for the power module that's on order to come in so you can put the more complicated one that you'll actually use on the challenge together. You have these, which are relatively inexpensive, fairly easy to get up and going, and you can practice flying on these. And then you can compare, like, once you get yours up and going, like how easy or hard it is to control. And you'll see tweaking some of the control parameters is going to be essential in order to try and get your quadcopter to control more similar to like what a more professional package would be like. But this is small enough. I don't know on the weight on this, so check on the weight. If it's below a certain weight, then it's fine. So the weight, look online. It's like 0.55 kilograms. So if something's under 0.55 kilograms, whatever that weight is, don't quote me on that exact weight, then you don't even need to register the drone for flying out because it's so small. So if it's over that, then you got to register. So I think this might be under. In any case, you can fly it around indoors. This is well behaved enough. It should be okay to fly around and not be too crazy. And its rotors are way smaller than what you'd be using. It's way less power, so it's safer in general. So this is a good one to learn. So rather than doing like the simulation, in the past we did have a simulator thing. Simulator wasn't great. It was using the same sort of controller that you'd be using, which was nice, but it was looking at a screen. It tried to simulate it, but I think actually flying is more useful to learn how to actually fly, even if it's a different actual machine. Yes.
You said that the object basically making it less possible. Is there where you can be weighing hard elements so that's
Yeah, so we can on the day to actually verify the weights. I think that's a good idea. On the rubric, what the question was about weight, and on the rubric, why am I not? Okay, just a second. Bam, you. All right. So on the rubric, there's weight reduction, which is that you design to try and minimize weight, and this we can absolutely like. I think it probably makes sense to just have a balance there on the day. We'll definitely have a balance to verify the sample return anyway, so we can just weigh the quadcopters ahead of time. Double check that.
and for the when you're getting samples,
Yeah. No, you can collect multiple at the same time if you don't have to like come back. And so you do have the option to send a quadcopter out, collect water, come back, and then now I can modify, maybe take off an attachment, put on another attachment, and then fly out. So you do have that option. But if you can in one fell swoop go and say, okay, here we do the water collection, and now we press a button and a servo winds a winch to get that out of the way and secured, and you do like you can do that. That does get a little bit tricky, but it's definitely a thing that you can do. And actually, one cool thing is that you can, if you're trying to attach additional servos to this, there are places to plug in to have additional servo control, and then be able to map that to a button on the controller, so that you can have like on your camera mount. If I want to take pictures looking forward, so some of the pictures are like of horizontal, like targets on a flat surface like that. Some are looking down at the ground. You could have a thing where you have a servo that controls the orientation of the camera to be able to flip a switch and change that in flight. You know, because that's the thing you're designing is the camera mount. That can be a little bit tricky. You could also land the thing, manually adjust something, take it back off, but you have to bring it back to you to do that. Yes, please.
are we allowed to let's say another robot on the platform?
So the question is, for the sample collection, are we allowed to have another robot on the quadcopter or on the platform? In the environment rather than the drone. So like a completely separate physical object that moves around separate from the drone? No. So no. Yeah. So you're allowed to have like a separate system if you wanted to have like an Arduino running on your drone or a Raspberry Pi or whatever that is either talking to your flight controller or even just a completely separate system that's not like two completely electrically separated systems that are running separately. You can have that, but it needs to be all on the same quadcopter. You can have it communicate with a laptop or some other, like if you wanted some base system that like it's a robot, but like it can't be moving around inside where it has to be stationary, yeah, and it has to be outside of either attached to the quadcopter itself or outside of the area. So basically, the only thing that's allowed to go into the arena, essentially the 20-foot by 20-foot area that we're exploring, is the quadcopter. Everything else needs to be able to be outside. Other questions? Sorry, I didn't quite hear.
If they add any capability from the
That's correct. That's right. So as far as the overall weight of your thing, since you're doing things, like if you're trying to, whatever it is, like your camera is going to go on there, it's going to weigh something, like you're going to have weight that's going to go on there. we're trying to reward people who, as part of the, for example, the camera design, you might want to consider how much it weighs, right? Anytime you're doing aerospace, and especially anytime you're doing things that are going to have to go on a rocket to another planet, like as things get heavier, you need more fuel, which then weighs more to then carry it up, right? So like keeping weight down, we're trying to incentivize people in your design to try and keep the weight low, not necessarily to be less weight than this, but like your bare bones thing, but to try and like, it's going to be compared against other quadcopters who are also trying to accomplish these tasks. So from that perspective, hopefully it's a relatively fair comparison maybe. And if there are concerns about like comparing apples to apples, like what if I have a modular system where I have different modules, but not all of them are going to be on there at the same time? Like we can decide and just make sure it's clearly communicated, and we'll put it up on the website. Like, how is it going to be weighed, right? Weighed with like any modules not attached, or weighed with like, okay, your camera has to be attached, your rotor guards definitely have to be attached, but you know. That makes sense to me, right? Where you kind of have like a set weight where like, here's my expected weight, right? And if you want to include any potential attachments where even if it wouldn't all be flying together, if you've got any attachments you plan to use on the day, just include them all together and have it all as one. Like, I'm fine with doing that. And we could also change this if you want to weight it more towards innovative weight reduction so that the overall weight is a little bit less. We can maybe do 5 and 5 so that absolute lightest still can get the points for that. But then people like, okay, yeah, it weighs more, but it has a lot more capability, so the judges have some more leeway on there. We can change that.
Yeah, you got the creative and finding ways to make it way less.
Yeah. Yeah, and part of what we're doing here with this somewhat large quadcopter for what we're doing is like you have the ability to add a lot of weight to this. So you have that flexibility, and this is trying to encourage you to be judicious with that and not just be like, well, since we can carry a lot of stuff, let's just add a lot of stuff on. Yes, please. So the $250 limit is specifically a limit for stuff that you're wanting to get reimbursed by the space grant for, or have the space grant buy for you. As far as other things that you want to use for it, we haven't found the need to restrict, like, because we don't want like, oh, well, I used some of my solder that I just had lying around in my lab or whatever, right? Or so a Velcro strip that I just bought, right? Like, so in general, if you have other expenses that you're just covering separately, then that doesn't have to fit in the limit. So basically, $250 is what will get reimbursed, what you can get reimbursed. Yeah, if you have, yeah, if your homeschool has some like robotics club or something like that that can buy some stuff, you're welcome to use that. If we find that it's like, oh, one team, like if after the year we find that that's super unfair, we can always change it for next year. But we've done this for a number of years and we've never had an issue in the past. So in general, those sorts of things, it's, you know, I don't know. I started like 15 sentences and kind of didn't end any of them. But the point I was trying to get at is that there are different resources based on like, some people have access to rooms, some people have access to flying on their campus, whereas other people can't, right? So it's not perfectly equal between the different teams just based on what you have access at your home campuses, but we're trying to make it so that at least on the base stuff and on the ability to like purchase your things, that's all level playing field. I'll also add that if anybody wants me to laser cut stuff for them from QV, I'm happy to run the laser cutter. If you want, we're kind of out of the way, but if you're willing to make the drive over, I can let, you know, you can run it yourself and do a lot of iterations or whatever. But if you just have a part that you want to send over for me to laser cut and be like, I want this out of this material, like I even have a variety of just stock, basically acrylic is what I generally use. If you want it out of like some other type of wood or whatever, you probably need to get that to me. But I'm happy to let you use that equipment. almost, yeah. Yeah, and I actually worked with Professor Ravindra Tama from the Central Connecticut State University mechatronics program over the summer on this sort of stuff. And so I can ping him and see if what capabilities he has as well. But you're welcome to use whatever capability you have on your own campus. Like, don't feel bad for using whatever resources you have at your disposal. Yeah, just use those. Like, yeah, you can get other resources if you have like a corporate sponsor, or you have like somebody has hobbyist equipment that they own or whatever. That's all fine.
Yeah, no, I have.
Yeah.
Then they want us.
Yeah. Yeah, no, yeah. Make sure they're listed on the poster. Make sure you get thanks in the report. Yeah. I think I have, not for this thing, but for national robotics thing, I got various local manufacturing companies to help pay for the flights and that sort of stuff. And said thanks, and it was good. So yeah.
Jacob, you talked about where the challenge is going to be.
Yeah, so the challenge hopefully will be at CCSU. We're still finalizing the details on that. If not CCSU, it'll be Quinnebog Valley Community College. But we, knock on wood, hopefully it'll be at CCSU. And the date I had on there, April 29th or whatever, it's that Friday, the last Friday in April is the plan. All right, if there are no other questions, I'll go ahead and I'm going to stop the recording.